Hello and welcome to the channel. Let's talk about SSH. If you are in tech, you use it. It's the absolute backbone for managing servers remotely. But let's be real, managing who has access can be a total mess of static keys, password prompts, and just headaches. It's time for a better way. So just imagine for a moment, what if instead of digging around for the right password or a specific key file, your SSH login was as easy as signing into, say, your Google account? What if it was just one click and you're in? Today, I'm going to show you a way to log into any server as easily as logging into Gmail without sacrificing security. Okay, let's unpack this. You are probably familiar with the classic way to connect to a server via SSH, right? I mean, for years, you've just typed SSH followed by a username and IP address or hostname. Something like SSH Philip at Node1. Then, you punch in a password or maybe rely on your SSH key. It's the standard, really, the reliable workhorse, and well, it just works. Check this out. The command I will type looks almost exactly like what you are already used to. You see that? There's just one tiny addition. You add a proxy at the end. That's it. And instead of the usual password prompt, you suddenly get a verification URL and a user code. So you grab your phone or maybe a laptop, open that URL, and authenticate through your normal identity provider. We used Google in the demo. You might even use a hardware key you already have set up, and bam! You are already logged into your server. But here's where it gets really interesting. If you try the same command again, like right after, you get logged in immediately. No more browser prompts. You're already authenticated. And how long that lasts, that's actually customizable with cookie expiration setting. It feels, well, effortless. And this seemingly simple new approach, the one that makes secure SSH feel so smooth, it's powered by a tool called Pomerium. So in this deep dive, I will basically peel back those layers, demystify the magic. We're going to get into exactly how Pomerium acts as this identity-aware reverse proxy, how it protects your SSH servers, centralize the whole authentication mess, and just simplifies access. We look at the tech details underneath, and maybe more importantly, explore the why this matters part. So yeah, at its core, Pomerium is exactly that. An identity-aware reverse proxy that can not only proxy HTTP, but also SSH. Think of it like a really smart, secure gatekeeper sitting right in front of all your SSH servers. Instead of your servers just being out there on the internet, Pomerium handles all the incoming connection first, and the setup, it gives you some pretty compelling advantages. First off, centralized identity. So instead of managing users' accounts on every single server, Pomerium hooks your SSH access into external identity providers, IDPs like Google, Okta, Azure, you name it, which immediately means enhanced security, right? You get to leverage single sign-on, SSO, and multi-factor authentication, MFA, that you are probably already using with those IDPs. Then there's policy enforcement. Pomerium carefully checks authentication and authorization policies before any connection even gets near your backend servers. You can set up really granular rules based on identity stuff like email address, group membership, to control exactly who gets access to which server. It also provides direct exposure protection to your actual SSH servers. They are safely tucked away behind Pomerium, not directly facing the internet. Pomerium is the only way in. And finally, this is the big one, dynamic credentials. After you successfully authenticate, Pomerium dynamically issues those short-lived SSH certificates. They completely replace the need for static, long-lived SSH keys. It's a real game changer. Speaking about policy enforcement, like what happens if someone tries to access a server they shouldn't? Let's say you are trying to SSH as user Philip onto Node1 going through your Pomerium proxy. In Pomerium's config file, you might have a really simple policy. Access is only allowed if the logged-in user email is exactly philip at linuxcloudhacks.ovh. Now, you, the user, you might authenticate successfully through your IDP. Let's say Google verifies it's really you. But if your verified email address isn't philip@linuxcloudhacks.vh, Pomerium just denies the connection, flat out. You authenticated, you proved who you are, but the authorization policy didn't match. Pomerium's job is to be that intelligent gatekeeper. It checks not just who you are, but also what you are actually allowed to do. Remember, authentication is to prove it's really you, and authorization is what you can and cannot do. Why you should really care about using an IDP for SSH? I mean, what problem does it solve that good old-fashioned SSH authentication struggles with? Well, think about traditional password authentication for SSH. Each server has its own local list of usernames and passwords, right? That works fine for maybe like 5 servers. But imagine managing hundreds or thousands. It quickly becomes a total nightmare trying to keep track of who has access where, ensuring passwords meet policy, dealing with leavers, inconsistent account expiration is a huge headache. It's just a decentralized mess. Okay, sure. An improvement is centralizing user management, maybe using something like LDAP. All servers authenticate against one shared directory. That's better. But an identity provider, an IDP, takes this a huge leap forward. Its whole job, its reason for existing, is to authenticate users and then basically vouch for their identity to other systems. It's the ultimate authority that says, yep, this person is who they claim to be, and here's the proof. And with modern protocols like OpenID Connect, applications can just completely hand off the authentication process to a trusted third party like Google, Microsoft, Okta, whoever. So instead of every single app trying to figure out if you are who you say you are, they just ask the IDP you trust. This gives massive benefits to you, the user. Things like centralize credential management, change your password once, update your security key once, enable multi-factor authentication once. All connected apps just benefit, and of course single sign-on. Log in once to your IDP, and then all the other connected applications just recognize you. It's security, convenience, consistency, all rolled together. So let's see the full Pomerium connection flow. Here's what happens when you, the client, try to connect to Pomerium listening on port 22. First, Pomerium cleverly prompts you to log in via your configured identity provider. Assuming the authentication succeeds and you pass all the policy checks Pomerium has configured, Pomerium then uses its own CA key to sign a fresh short-lived SSH certificate specifically for you right then and there. Then, Pomerium turns around and uses that certificate you just created to authenticate to the actual target server on your behalf. And importantly, the entire SSH session from your client to the backend servers run through Pomerium. It's not just like a simple TCP tunnel. Pomerium actively terminates your connection and then establishes a new one to the backend. This active role is what lets Pomerium enforce those access policies continuously and log everything. You get a complete audit trail. It's like a dedicated traffic cop for every SSH session. When you think about setting up an IDP for something that's always been so command line focused like SSH, you know, IDPs usually work by redirecting you to a web browser page to log in. But your SSH client running in a terminal, it doesn't have a browser. How does Pomerium actually bridge that gap? That's a pretty fundamental challenge. But Pomerium tackles this with a really clever mechanism called the device authorization flow, also called the device code flow. It's exactly what you saw in the initial demo. When you type that special SSH command, Pomerium contacts an IDP that generates a unique temporary code and gives you a web link. Let's simulate that from the command line. I have a script that calls our IDP device code endpoint. We only provide the client ID and ask for ID token, profile, and email scopes. Let's run it. We got a verification link with user code that's valid only for 900 seconds. You just open that link on your phone, laptop, whatever's handy, confirm the code, and then you complete your normal login through Google or whichever IDP you are set up. Standard stuff. I was already authenticated, so I'm in. Now let's copy the device code. That's a claim ticket for this one login attempt that we'll use to get the access token. I have a script handy. Let me paste the device code here. We'll be pulling the token endpoint. Let's do that now. The response includes access token and ID token. This confirms that the user has authenticated. ID token provides user identity information. We did request email scope, so user email should be there. Let me decode that ID token as it's a JWT. I will copy it and paste it here. Here's the email. Another way to get the email is to call the user info endpoint. It's now possible because we have the access token. Let me do that. I have a script handy. Now, I will just paste the access token and run the script. We got the email. That's exactly how Pomerium uses IDP to authenticate users. So, long story short, no browser is needed on the machine running the SSH command itself. It's essentially a bridge between your command line and your trusted web identity. And honestly, it works remarkably well. Client authentication with device code only covers client connecting to the Pomerium part. What about connection from Pomerium to the backend servers? The magic is built on SSH certificates. Let's just quickly walk through the basic steps involved manually, just so we can really appreciate what Pomerium is automating for us later on. So, fundamentally, an SSH certificate is basically a public key that has been cryptographically signed by a trusted third party, a certificate authority. Think of it like a digital ID card for your SSH key issued by someone everyone trusts. Setting this up manually meant a few steps. First, you generate a master CA key pair. This is the key the CA, or in our case Pomerium acting as a CA, uses to sign individual user SSH keys. Then each user would generate their own regular SSH key pair. The critical step is using the CA's private key to sign the user's public key. That creates the actual certificate file. And crucially, you can embed things in that certificate, like an expiration time and the username that the user is allowed to log in as. That's a huge security win right there. This certificate will expire. So once you have that signed certificate, how do you actually get the server to trust it? And what's the big win compared to just, copying public keys into authorized keys everywhere? That's where the real simplification happens. Instead of managing potentially hundreds, even thousands of individual public keys across all your servers, in those authorized key files, you just configure your target SSH server once to trust the CA's public key. That single key. Let's copy the CA public key to the target server. Now let me go to the target server and move that CA public key to the etc SSH folder. Then let's adjust some permissions. Next, let me create a new SSH configuration file. In the config file, I will specify the certificate authority public key to trust for verifying user certificates. So we say the SSH service, hey, trust certificates signed by this CA. Once that's done, any valid SSH certificate issued by your CA, the server will trust it. Finally, let's restart SSH to load the configuration. If I try connecting, I'm prompted for a password. However, if we connect using a private key plus the certificate, then the server basically says, aha, this cert is signed by CA I trust. It hasn't expired and it's valid for this user, come on in. And that's exactly why certificate-based authentication is so powerful. Let's move to the setup part. I will start with registering with an identity provider. Now a little wrinkle here. Not all IDPs implement this specific device code flow in exactly the way Pomerium expects. For our demo setup, I actually found a neat workaround. I'm using Auth0 as an intermediary. For some reason, and I spent a bit of time banging my head against this, Google's direct implementation of the device authorization flow just didn't want to play nice with Pomerium. Tricky, but Auth0, it supports the flow perfectly in a candidate as a bridge. So, the setup involves configuring Auth0 to basically delegate authentication to Google. It's called federated identity. When Pomerium sends you to Auth0, Auth0 then sends you to Google to actually verify who you are. This way, you still use your trusted Google credentials. To register, let's go to auth0.com and click sign up. Then I will click continue with Google. Let me provide my email, select the account type. After a short while, we are presented with Auth0's main console. To improve the security, I will add a second authentication factor. Let me go to my profile and add Google Authenticator. Auth0 identity provider can authenticate you against a database. However, it can delegate that to yet another identity provider acting as an identity broker. As you can see, there are plenty to choose from. The one that we will be using today is Google. To use Google as the IDP, we need a client ID and a client secret. Let me go to Google Cloud Console and navigate to APIs and Services, and then Credentials. Next, let me click Create Credentials and select Auth Client ID. As the application type, I will choose Web Application. Let's name it Auth0. Then we need to specify an authorized redirect URL. That's the URL the client will be redirected to after login. Let me go back to Auth0, Applications, then I select the default app and copy the domain. Now let's paste that domain in Google's authorized redirect URLs. I will add /login/callback as the path and add HTTPS as the protocol. Then I will click Create. Next, let's copy the client ID and paste it in Auth0. Then let's copy the client secret and paste it in Auth0 as well. Finally, let's save the changes. Let me go back to Google, select the audience and change the application status to external and change it to production. Now, let me go back to Auth0 and test the integration. I will click Try Connection. Let's select the user and voila, it works. Auth0 did receive the user profiles back from Google. With that said, we have set Google as the identity provider in Auth0. Once that Auth0 to Google link is set up, we can create a new application within Auth0 specifically for Pomerium. Critically, this app needs to be set as a native application type because only native apps support this device code flow. I will name it SSH. Then let's click Create. From that application settings tab, we'll grab that essential bits. The endpoint URL, the client ID, and the client secret. Those are the credentials Pomerium needs to talk to Auth0. But first, we need to enable device code authorization. I will scroll down to the bottom, select Advanced Settings, and then Grant Types. Next, let me tick Device Code Grant and click Save. Lastly, in the Connections tab, I will disable authentication against the database, leaving only Google IDP. Finally, let's save the config. Okay, so we've got our identity provider sorted out, maybe with that auth bridge. How do we then bring this all together and set up Pomerium itself on the proxy server? Let me show you. I will be using Ubuntu 24.04. We'll run Pomerium in a Docker container as it seems like the go-to method these days. It's generally just easier that way. That flexibility with Docker is a huge plus, especially for getting started quickly and ensuring consistency between, say, testing and production. We need to free up port 22, the default SSH port, because Pomerium needs to listen there. This usually means editing your existing OpenSSH server configuration to make it listen on a different port, like say 2222. Then let's restart that SSH service. To test it, I will log out from the server and log back in, but this time using the new port. Works. Now, port 22 should be free for Pomerium. Setting up Pomerium on the actual proxy machine is pretty streamlined. First, we'll want to make sure any old temporary SSH keys or certs we might have made for testing are cleaned up. Pomerium handles all that dynamically now. Then remember, Pomerium itself acts like an SSH server to your client, so it needs its own host keys. Usually you generate ED25519, then generate RSA, and lastly, ECDSA keys, so clients connecting to Pomerium can verify its identity. Okay, let's see if the host keys have been created. Keys are there. After that, we create Pomerium's main configuration file, usually called config.yaml. This is where we tell Pomerium everything it needs to know. I did prepare a minimal template that's missing only a few parts. Here we specify our identity provider, Auth0 in this case, then copy-paste that provider URL, next copy-paste that client ID, and copy and paste in client secret from Auth0. We also point Pomerium to the CA private key it should use for signing users' certificates and host keys it should present to the clients. And most importantly, this is where we define our access policies. Node 1 is the connection alias, and 192.168.10.230 is the actual backend server. Connection is allowed only if the authenticated user's email matches philip@linuxcloudhacks.ovh. It's a really clear, declarative way to spell out exactly who can access what. Now let's look at the Docker Compose file. It's very straightforward. We tell it to use the latest Pomerium Docker image, then we map our config YAML file and all those important SSH keys, the CA key and the host keys into the container so Pomerium can read them. And finally, we expose port 22 on the host machine, mapping it to port 22 inside the running container. It keeps everything nicely packaged, isolated, and makes managing dependencies much easier. While we can install it directly, containerization is definitely the preferred route in most modern setups. It just simplifies the whole process significantly. So, once the Docker Compose file is ready, we just run a simple command, docker compose app-d. That starts the Pomerium container running in the background. You can check if it's running with docker ps. And that's pretty much it. Our Pomerium proxy is up, listening on port 22, ready to guard your SSH access using those identity-aware policies we talked about. And that's it for today. This new identity-aware model is all about who you are. Your access is granted because you can prove your identity through a system you already trust at the exact moment you need it. It's dynamic, it's safer, and it's just a much better way to operate. So that really leaves us with one last question to think about. Take a look at your own systems. Is your infrastructure built on a messy pile of static permanent credentials, or is it built on a modern foundation of verifiable identity? Something to think about. You can find all my config files on my GitHub, and I'll link it in the description. Thanks for watching, and I'll see you in the next video.